In this video, I'm gonna talk about the redox reaction that underlies the cellular respiration. What you see up here with the methane, oxygen, carbon dioxide, energy, and water with the arrow to the right, this is what we call a chemical equation. So initially, we're combining the methane with the oxygen, and then we are forming the carbon dioxide, energy, and water. This is specifically what we call a combustion reaction. When you take the oxygen as a reactant and water and carbon dioxide as product. Well, before we get into the redox, it's just simple way of saying reduction and oxidation together. And oxidation is defined as loss of an electron or loss of electrons, whereas reduction means gain of electron. Okay, we can illustrate using this bonding diagram. You can see the carbon and hydrogen have very similar electronegativity values, therefore the electrons are shared very equally for all CH bond. But this is becoming oxidized, meaning the oxygen gains those electrons, whereas the carbon loses them. Therefore, since carbon lost the electron to oxygen, and oxygen gained those electrons, we call that oxidized. On the other hand, the oxygen equally shared the bonding electrons, but oxygen gained those electrons as it bonds with hydrogen. Therefore, oxygen gained these electrons, and we call this state as reduction. Another easy way for those who have not taken chemistry is anytime you see a carbon attached to a bunch of hydrogen and they are having less hydrogen or connected with the oxygen, or oxygen is involved with the carbon, that's simply oxidation, or we call that organic molecule is oxidized. On the other hand, the oxygen attaches a bunch of hydrogen, we call that a reduction. Okay, so that's for those who have not learned the electrochemistry part of chemistry. And for those who learned regular chemistry before, well, let's do the oxidation number. So carbon here, I'm gonna call that X because that's what we are looking for. We're mainly concerned with the carbon from the organic molecule, and the hydrogen takes +1 oxidation number, but there are 4 of them. All the compounds in the chemical equation are 0, and the X must be -4. Whereas the carbon dioxide, the oxygen takes -2 most of the times, and there are 2 of them. Since it's a neutral, we set that equal to 0. And the carbon, I'm gonna call that X. So the X has to be +4. So that means the oxidation number of methane increased to carbon, the +4 on the carbon dioxide. So anytime number increase, that's oxidation. And then you can imagine how the reduction takes the decrease in the oxidation number. Oxygen by itself as in pure form gonna take 0. Okay? Any diatomic molecules you see, or any pure element of metals, you're gonna assign it 0. Since we're concerned with the oxygen, we'll call that oxidation number of oxygen to be 0. And then there are 2 hydrogen. Obviously hydrogens are less electronegative, so it takes a plus charge, and then there are 2 of them. Oh, what's that? two of them. So sorry about that. I don't know what's wrong with this writing. Alright, it has to be equal to 0 because again the water is not polar. It is polar, I'm sorry. It doesn't have charge, so I set it equal to 0, and the x has to be -2. And again, we are particularly concerned with the oxygen here, so let me highlight that. And then here we are concerned with carbon. Therefore the oxygen gained the electrons. That's why you see the negative charge, and that's what we call reduction. Okay, so this oxidation and reduction becomes very prominent when we talk about the NADH, the electron carrier, formed from NAD plus and in the inorganic phosphate. And then we'll see a bunch of these reactions that shows the reduction coupled with oxidation throughout the cellular respiration as well as in the photosynthesis chapter.